With just a pair of hands and a bright light, you can cast a crisp animal silhouette. Step outside, and that same silhouette becomes a massive, distorted shape trailing across a playground. It behaves like a physical entity, a dark gas or a substance you might try to reach out to and capture in a jar. But in total darkness, that presence vanishes completely. A shadow marks a localized absence of light. Understanding the dark requires looking at the light itself. Light follows the rule of rectilinear propagation, traveling in strictly straight, unbending lines through empty space. When a solid object slides into that path, the straight rays hit the front edge and stop, carving out a void directly behind it. This process relies on three absolute requirements: a light source, a physical blocker, and a receiving surface. Because shadows depend on these physical components, we can control every aspect of their appearance. The first variable is the material of the blocker. A clear plastic sheet moves in front of the light, casting almost no shadow. Transparent materials like this allow almost all light rays to pass through uninterrupted. Translucent materials, such as frosted glass, scatter those rays. Only some light makes it through, creating a pale, weak shadow. Opaque materials, like wood, stop the light entirely, resulting in a solid, deep black void. The darkness of a shadow measures exactly how much light energy a material allows to pass through. The second variable is distance. Yellow rays diverge from a point source, grazing a book to hit the screen. Moving the book closer to the light spreads the rays, expanding the shadow. Moving it away shrinks the shadow to match its physical size. The size of a shadow is a geometric ratio dictated by the object's proximity to the light source. The final variable determines whether shadow edges appear razor sharp or soft and blurry, the type of light source. A point source, like a tiny LED, originates from one coordinate, creating a single, hard boundary. A wider, extended source allows light to hit the object from multiple angles. These overlapping paths bleed into the dark zone, creating a fuzzy transition. This blurriness provides physical evidence of light paths hitting the same edge from different origins. These rules apply beyond the lab, governed by the ultimate light source, the sun. In the early morning, the sun's low angle acts like a flashlight pointed sideways, stretching shadows across the field. At solar noon, the steep overhead angle minimizes the blocked profile, resulting in the shortest shadows of the day. The changing shape of a tree's shadow tracks the Earth's rotation relative to straight solar rays. Consider a creative challenge, designing stage lighting for a play to make a normal-sized actor look like a towering monster on a backdrop. To maximize the geometric expansion, the actor needs to stand as close to the light source as possible. For terrifyingly sharp and defined edges, the designer would choose a tiny, bare bulb over a large, soft lighting panel. Shadows follow the predictable geometry of interrupted light, allowing for precise control of their shape and scale.